So, good morning, friends. Today we are going to discuss about the construction and working of KAPLAN turbine. So, water turbines, generally we have three types of water turbines. The first one, Pelton turbine, second one, Francis turbine, and third one, which is called as KAPLAN turbine. So Pelton turbine, generally it will be taking maximum energy that is present in the liquid. So therefore it will be using less quantity of water for power generation. And on the other hand, KAPLAN turbine will be taking less amount of energy from the liquid. So therefore, it will be using more quantity of water for power generation. And finally, coming to the Francis turbine, so it will be taking energy of the liquid in moderate quantities. So therefore, it will be using water in moderate quantities for power generation. So depending upon the availability of quantity of water, so we have to make use of these turbines. So if water is available in less quantities, we have to make use of Pelton turbine for power generation. If water is available in moderate quantities, we have to use Francis turbine for power generation. And finally, if water is available in large quantities, we can use KAPLAN turbine for power generation. So friends, depending upon the availability of water, so we have three types of turbines for power generation. So depending upon the availability of water, so we have to select any one of these turbines. And so here, this is the slide which indicates the sectional elevation and top view of KAPLAN turbine. So sectional elevation shown on the top of the slide, and top view it is shown on the bottom of the slide. So first figure is used for indicating the sectional elevation of KAPLAN turbine, and the second figure it is used for indicating the top view of the KAPLAN turbine. And basically this KAPLAN turbine is mounted on a vertical shaft. So it's called as a vertical shaft turbine. And the shaft of the turbine will be rotating at around 1000 RPM. So therefore it is called as a high speed turbine. And finally, it will be taking less quantity, it will be taking less amount of energy present in the liquid. So therefore, it is called as low head turbine, and it will be taking water in more quantities for power generation. So it is called as a high discharge turbine. And finally, water will be entering and leaving the runner in axial direction, that is parallel to the axis of the shaft. So therefore, it is called as axial flow turbine, and water will be flowing from outer diameter to the inner diameter of the runner. So therefore, it is called as a inward flow turbine. And finally, the pressure of the liquid which is entering the runner will be greater than the pressure of the liquid that is leaving the runner. So that means inlet pressure will be greater than atmospheric pressure, and outlet pressure of the runner will be less than atmospheric pressure. So this difference of pressure, which is called as reaction pressure, difference between inlet and outlet pressures of the runner, that is called as reaction pressure. So this reaction pressure is very essential for operating the turbine. So therefore, it is called as reaction turbine. And finally, as mentioned just now, the outlet pressure of the runner will be less than atmospheric pressure. So that means negative pressure will be developed at the outlet of the runner. So therefore, a draft tube is very essential for operating this turbine. So this way, it is as a whole, it is called as inward axial flow reaction turbine. And finally, as mentioned earlier, the shaft of the turbine will be arranged in vertical position. So therefore, the shaft of the generator must be also arranged in vertical position. So therefore, the generator will be placed above the turbine for power generation. So this is the arrangement of the KAPLAN turbine. Now, as I have already mentioned, the shaft will be arranged in the shaft of the turbine shaft will be arranged in vertical position. So therefore, it will be looking like a rectangle in the sectional elevation of the turbine, and at the same time, it will be appearing in the form of a circle in the top view of the machine. So this is the rectangle used for indicating the shaft of the machine, shaft of the turbine in sectional elevation. And this smallest circle that is used for indicating the shaft of the turbine in the top view of the machine. So friends, this is the arrangement of the KAPLAN turbine. Now, this shaft will be continuously rotating in clockwise direction as long as the machine is under operating conditions. And secondly, a rotating disc is mounted. You can see the disc here. So a rotating disc is mounted on the shaft of the turbine. So that is called as a runner. And in the case of KAPLAN turbine, 4 to 8 blades, around 8 blades are fitted around the periphery of the runner. That means in between the inner diameter and outer diameter of the runner. So they are called as runner blades. Now this shaft is mounted on, this runner is mounted on the shaft of the turbine. So therefore, the runner and the runner blades put together, it is referred to as a runner assembly. The runner assembly is mounted and fitted to the shaft of the turbine. So the shaft of the turbine is rotating in clockwise direction. Therefore, the runner assembly will be also rotating in clockwise direction as long as the turbine is under operating conditions. So these are the rotating parts. All other parts will remain in fixed position, stationary position. So, but these parts will be rotating in clockwise direction. The shaft of the runner of the machine, the blades of the runner. So all these items will be rotating. Only these items will be rotating in clockwise direction as long as the turbine is under operating conditions. And finally, a fixed wheel is put around the periphery of the runner. So the wheel is in fixed position. So it's called as a fixed wheel. So this fixed wheel, it is put around the periphery of the runner. So that is called as a guide wheel. And number of blades are fitted around the periphery of the guide wheel. That means blades are fitted in between the inner diameter and outer diameter of the guide wheel. They are called as guide blades. They are referred to as guide blades. Now, as the name itself implies, these guide blades are very, very essential for guiding water onto the runner blades in correct direction, in a required direction. So therefore, they are called as, guide blades of the machine. And apart from that, these guide blades, the guide wheel is fixed in position. The guide blades are also fixed in position. But the blades can move about their centers. So therefore, additionally, these guide blades are used for controlling the quantity of water that is entering the runner. So these are the, two functions of the guide blades. So firstly, they are meant for conveying water onto the runner blades in required direction, and at the same time, they are also used for controlling the quantity of water that is entering the runner according to the load acting on the turbine. So when the load on the turbine increases, it requires more quantity of water. So therefore, all the guide blades will be coming to open position, and more water will be entering the runner of the machine. Similarly, when the load on the turbine decreases, it requires less quantity of water. So we have to supply less quantity of water. So therefore, automatically the guide blades will be coming to closed position for supplying less quantity of water into the runner. So friends, as a whole, these guide blades are used for guiding water into the runner in proper direction, and at the same time, they are also used for controlling the quantity of water entering the turbine. So if a turbine requires more quantity of water, these guide blades will be coming to open position. If a turbine requires less quantity of water, these guide blades will be coming to closed position. Friends, a governor is used for operating the blades of the guide wheel mechanism. So when the turbine requires less quantity of water, so this governor will be closing all the blades of the guide wheel mechanism. And when the turbine needs more quantity of water, the same governor will be opening the blades of the guide wheel mechanism. So this is a wonderful arrangement required for operating the machine. So the first one called as guide wheel, and blades fitted to the guide wheel referred to as guide blades. So these items put together, it is referred to as a guide wheel mechanism. So as a whole, guide wheel mechanism meant for guiding water into the runner in required direction, and also for controlling the quantity of water which is entering the runner according to the as per the load acting on the turbine. So friends, this is about the arrangement of guide wheel mechanism. And finally, a casing is essential for any machine. We have to use a casing is required for covering the parts of the machine. So here also we have to use a casing for covering the parts of the turbine. So therefore, this is put around the periphery of the guide wheel, and this is made in the form of a spiral. So that's why it is referred to as a spiral casing. So spiral casing, I mean, meant for covering the parts of the turbine, the runner mechanism of the turbine, and also the guide wheel mechanism of the turbine. So therefore, a casing is put around the periphery of all these components, and it is made in the form of a spiral, Archimedean spiral. So therefore, it is referred to as a spiral casing. Friends, this is the inlet of the casing is shown. This has to be taken as the inlet of the casing, and the inlet of the casing is fitted to the pipeline that is coming from the head race reservoir. That means it is fitted to the penstock that is fixed inside the dam. So therefore, water coming out of the penstock will be entering the casing, and it will be flowing in clockwise direction. So friends, this is the arrangement of KAPLAN turbine. And finally, that means this top view is used for indicating, for explaining all the components of the KAPLAN turbine. And the draft tube is fitted below the runner. So therefore, it will not be visible in the top view of the turbine. So all the items will be visible in the form of circles in the top view of the machine. But the draft tube is fitted below the runner, so therefore it is not visible in the top view of the turbine. So therefore, friends, sectional elevation is very, very essential for indicating the arrangement of the draft. So we can see the arrangement of the draft tube. So it's very, very essential for operating Francis and KAPLAN turbines. Negative pressure will be developed at the outlet of the runner. So therefore, we have to make arrangements for removing the negative pressure of the liquid. Otherwise, it will result in cavitation. It will be damaging the blades of the runner. So therefore, a draft tube, so this draft tube is fitted to the, outlet of the runner. And friends, this inlet of the draft tube is circular in cross section, and outlet of the draft tube is rectangular in cross section, and the change of cross section is taking place in the bend portion of the draft tube. So draft tube is bent in the form of an elbow. So therefore, it is referred to as elbow type draft. So straight draft tubes are used suitable for operating Francis turbines, but bent type bent draft tubes are very, very essential for operating KAPLAN turbines. So here, for operating a KAPLAN turbine, a draft tube is bent in the form of an elbow. So therefore, it is called as elbow type draft tube. And as mentioned just now, the inlet of the draft tube will be circular in cross section, that is fitted to the outlet of the runner. And the outlet of the draft tube is rectangular in cross section, that is submerged in the tail race reservoir. So always, in any case, the exit, the outlet of the draft tube must be submerged in the tail race reservoir. Otherwise, air will be entering the draft tube and it will be destroying the pressure of the liquid that is flowing in the tube, and ultimately the efficiency of the draft tube will be getting reduced. So always the exit or outlet of the draft tube must be well below the level of water in the tail race reservoir. It's called as a tail water level. So always the exit of the draft tube must be at least 1 meter below the level of water present in the tail race reservoir. So friends, this is the arrangement of a draft tube, elbow type of draft tube. So very much required for operating the KAPLAN turbine. And friends, this is about the construction of the machine. Now coming to the working of the machine, water coming out, as I've already told you, the casing of the turbine will be fitted to the penstock that is coming from the first reservoir, dam and the first reservoir. So therefore, water coming out of the penstock will be entering the casing, and it will be flowing in clockwise direction. So therefore, the area of cross section of the casing is gradually decreasing in the direction of flow of water. So therefore, the pressure energy of the liquid will be getting converted into kinetic energy of the liquid. That means in the first stage, the casing is used, is very essential for raising the kinetic energy of the liquid. And secondly, water which is coming out of the casing will be entering the guide wheel, and it will be flowing from outer diameter to the inner diameter of the guide wheel. Again, the area is decreasing in the direction of flow of water. So therefore, again, pressure energy will be getting converted into kinetic energy of the liquid. Therefore, the guide wheel is also used in the second stage. The guide wheel is also used for raising the kinetic energy of the liquid. And finally, the liquid that is coming out of the guide wheel, it will be entering the runner, and it will be flowing from outer diameter to the inner diameter of the runner. Again, area is decreasing in the direction of flow of water. So therefore, in the third stage, again, pressure energy will be getting converted into kinetic energy of liquid. So friends, therefore, the runner is also used for raising the kinetic energy of the liquid. So energy conversion is taking place in 3 stages. Initially, the casing is raising the kinetic energy of the liquid. And secondly, in the second stage, the guide wheel is also raising the kinetic energy of the liquid. And in the final stage, the runner will be also raising the kinetic energy of the liquid. So this way, the turbine, initially the turbine will be converting the pressure energy into kinetic energy of the liquid, and finally it will be converting kinetic energy of the liquid into mechanical energy of the shaft, and ultimately the generator will be converting mechanical energy of the shaft into electrical energy, that is referred to as power generation. So friends, these components, namely this spiral casing, guide wheel mechanism, runner mechanism. So all these items, basically they are used in different stages. Basically they are used for raising the kinetic energy of the liquid, which is very, very essential for operating the turbine. And finally, friends, we can go to the sectional elevation. So we have talked about the arrangement of the draft tube. So all components can be explained with the help of the top view of the machine. And sectional elevation is very, very essential for explaining or showing the arrangement of the draft. So friends, the draft tube is fitted to the outlet of the runner. So water coming out of the runner will be entering the draft tube, and the area of the tube is again increasing in the direction of the flow of water. So pressure energy of the liquid increases. That means the kinetic energy will be getting converted into pressure energy of the liquid. So this way it can be used for destroying the negative pressure of the liquid that is available at the outlet of the runner. So friends, this draft tube initially it will be receiving the water that is coming out of the runner, and secondly it will be destroying the negative pressure of water. So it will be increasing the pressure energy of water, and finally it will be discharging the entire quantity of water onto the tail race reservoir. So these are the functions of various components. This is about the working of the machine, the spiral casing, guide wheel mechanism, runner mechanism. So all these items are used for raising the kinetic energy of the liquid. And after completion of the operation, this draft tube is used for raising the pressure energy of liquid before it is discharged into the tail race reservoir. So friends, these are the various components. We have seen the arrangement of the components. We have talked about the construction of the machine, functions of components, and also we have noted down the working of the machine. All items used for raising the kinetic energy of the liquid before power generation, and draft tube is used for raising the pressure energy of the liquid after power generation. So friends, this way we have thoroughly dealt with the construction and working of KAPLAN turbine. So as I've already told you, friends, top view is can be used for explaining all the components of the turbine, and front view can be used for explaining the draft tube of the machine. So this is called as a sectional elevation, first figure, and this is second figure. This is referred to as a plan or top view of the machine. So friends, before ending the session, let us make a quick review of the information which we have seen in this particular section. So let us, friends, let us note down the salient features. These are the salient features of a KAPLAN turbine. So water is flowing from outer diameter to the inner diameter of the runner. It's called as inward flow turbine, and water will be entering and leaving the runner in axial direction. So it's called as axial flow turbine, and inlet pressure of the runner will be greater than the outlet pressure of the runner. So this pressure difference called as reaction pressure, very, very useful, essential for operating the machine. So it is called as a reaction turbine. And friends, this machine will be taking less amount of energy from the liquid, and therefore it's called as a low head turbine. And on the other hand, it will be taking it will be using more quantity of water for doing power generation. It's called as a high discharge, turbine. And energy of the liquid that is consumed by the turbine, that's called as net head of the turbine, capital H for indicating this parameter. So a KAPLAN turbine, the net head of the KAPLAN turbine will be around 60 meters only. Energy is expressed in terms of meters of water. So it will be around 60 meters of water. So this value, these values are also very, very important while explaining the working of these machines. And friends, the speed, the turbine will be rotating, the shaft of the turbine will be rotating at a very high speed, capital N for indicating this parameter. So the speed of a KAPLAN turbine will be around 1,000 revolution per minute. So therefore, it is called as a high speed turbine. And secondly, very less number of blades are fitted to the runner. KAPLAN runner is fitted with 8 blades. Francis runner fitted with 24 blades. And Pelton runner, it is fitted with around 40 blades. So we are using less number of blades for handling more quantity of water. So therefore, only 4 to 8 blades are fitted around the periphery of the runner. And similarly, it's mounted on a vertical shaft. So therefore, generator will be coming above the turbine. And we have also talked about the draft tube. Elbow draft tube is very, very essential for operating the turbine. And centrifugal governor is used for controlling the blades of the guide wheel mechanism. And one more governor is used for controlling the blades of the runner mechanism. So friends, both guide blades and runner blades are adjustable. So just like Pelton and Francis turbine, centrifugal governor is here. It is used for controlling the blades of guide wheel mechanism. One more governor is used for controlling the blades of the runner mechanism. So friends, these are the salient features of KAPLAN turbine. And we can make a note of these components. So the first one called as a turbine shaft held in vertical position. Generator is placed above the turbine. So both the shafts will be held in vertical position. Both the shafts will be rotating in clockwise direction. So turbine will be converting kinetic energy into mechanical energy of the shaft. And finally, the generator will be converting mechanical energy of the shaft into electrical energy. That's referred to as power generation. And runner, this is the important component, very vital component of the turbine. So a rotor is mounted on the shaft of the turbine, that is called as a runner. And a number of blades are fitted around the periphery of the runner. They are called as runner blades. So it is used for raising the kinetic energy of the liquid, and water will be flowing from outer diameter to the inner diameter of the runner, and water will be entering and leaving the runner in axial direction. And finally, minimum number of blades are sufficient for operating the runner of KAPLAN turbine. So runner is the most important component of this turbine. So we have talked about the guide wheel mechanism. A fixed wheel is put on the periphery of the runner. The number of blades are fitted to the, this is called as guide wheel. Number of blades are fitted to the periphery of the guide wheel. They're called as guide blades. So these guide blades will be guiding water into the runner in proper direction, required direction. And also they are useful for controlling the quantity of water that is entering the runner. And finally, this guide wheel mechanism is also used for raising the kinetic energy of the liquid. And friends, we have talked about the draft tube of the machine. So this is very, essential, another essential component of the turbine. So that is very, very useful after doing the power generation. So this draft tube is fitted to the outlet of the runner. So it will be receiving the entire quantity of water coming out of the runner, and it will be raising the pressure energy of the liquid coming out of the runner. And finally, it will be discharging the entire quantity of liquid onto the tail race. So friends, these are the main functions of the draft tube: receiving water coming out of the runner, raising the pressure of water coming out of the runner, and discharging the entire quantity of water onto the tail race. So these are the main activities of this component. And here in the case of KAPLAN turbine, a bent tube is very essential for KAPLAN turbine. So it's bent, the tube is bent in the form of an elbow. So it's called as an elbow type draft tube. And inlet of the tube will be in circular in cross section, that is fitted to the outlet of the runner. And the outlet of the draft tube is rectangular in cross section, that is actually submerged in the tail race reservoir. So friends, draft tube is essential for both for Francis and KAPLAN turbines. Negative pressure will be developed at the outlet of the runner. So draft tube is very, very essential for Francis and KAPLAN turbines. But whereas negative pressure is not developed in Pelton turbine, so therefore no need to use a draft tube in the case of Pelton turbine. But it's very, very essential for Francis and KAPLAN turbines. And moreover, a straight draft tube is, very much required for Francis turbine. And elbow draft tube is very, very, essential for KAPLAN turbine. So as a whole, the purpose of the draft tube is one and the same in both the cases. Receiving water, receiving water from the runner, raising the pressure of water and discharging water into the tail race. So the functions of the draft tube are one and the same in both the turbines, that is in Francis and KAPLAN turbines. However, a straight draft tube must be used for a Francis turbine, and elbow draft tube is very, very essential for operating a KAPLAN turbine. And friends, we can note down the differences between Francis and KAPLAN turbines. So 24 blades required for runner of the Francis turbine. The 8 blades are sufficient for the runner of the KAPLAN turbine. Similarly, water will be entering the runner in radial direction and it will be leaving the runner in axial direction. So Francis turbine is called as a mixed flow turbine. Whereas in the case of a KAPLAN turbine, water will be entering and leaving the runner in axial direction. So therefore, it is called as an axial flow turbine. And friends, just now we have talked about the arrangement of draft tubes. A straight tube required for Francis turbine, bent elbow tube required for KAPLAN turbine. So this is one of the differences between the two machines. And Francis turbine will be the shaft. The shaft of the Francis turbine will be operating at around 300 RPM, and the KAPLAN turbine will be operating at around 1000 RPM. And Francis turbine will be taking around 200 meters of energy present in the liquid. The KAPLAN turbine will be using only 60 meters, at around 60 meters of energy that is present in the liquid. And Francis turbine will be consuming, it will be using water in moderate quantities. KAPLAN turbines will be using water in large quantities, and ultimately, the blades of the guide blades of the Francis turbine are adjustable, but whereas in the case of KAPLAN turbine, runner blades are also adjustable. That means in the case of Francis turbine, only one governor is used for adjusting the blades of the guide wheel. But here, 2 governors are used in the case of KAPLAN turbine. One governor for adjusting the guide blades, another governor for adjusting the runner blades of the machine. So friends, these are the differences, major differences between Francis and KAPLAN turbines. So as a whole, we have discussed about the construction and working of KAPLAN turbine, functions and arrangements of components, differences between Francis and KAPLAN turbines, and the arrangement of draft tube for operating the KAPLAN turbine. So thank you so much for joining the session. Thank you.